Well, I'm flattered. I asked you to come back and you did. Thank you. So here we are. Solve the inequality x squared plus x plus 2 is positive and graph the solution set. So we're going to do this the way that we have done other ones. Find a y-intercept and try to find the x-intercepts, and there aren't any. Okay, if you tried to find the x-intercept, you would be trying to solve x squared plus x plus 2 equals 0. You would say, can I factor this? I can't figure out how to do it, which doesn't automatically mean there are none. It just means I should default to using the quadratic formula. X equals -1 plus or minus the square root of 1 squared minus 4 times 1 times 2 over 2 times 1. The discriminant is negative, okay, which means that there are no x-intercepts. We find the vertex using the same way we've done it. Notice we're not going to go through all the steps of everything every time. Okay? Finding the vertex is something that was really introduced in an earlier section. So by this point, we just kind of say, find the vertex. Here it is. It's -1/2 7/4. If you need to refresh how to find the vertex, go back to an earlier section. Okay? It's x equals -b over 2a, which is -1 over 2 times 1, or -1/2. There's the -1/2. And the y-coordinate of the vertex is just f of -1/2. So I would do -1/2 squared plus -1/2 plus 2, which works out to be 7/4. Okay? Because this is something we've done many times by now, we save time by just saying the vertex is at this. You should be able to find it on your own. Okay. We have a vertex with a positive value of y. And it's concave up. So I have a positive minimum value, and then I open up to be bigger than that. There are no intercepts. Okay? And the original problem said, where is this parabola positive? It's always positive. Okay? The solution set is all real numbers. Okay. So just to remind you of what can go wrong, okay, when you are asked to solve a quadratic inequality, I think the best way to do it is always make it compared to 0. Okay, I'm actually going to go to a blank screen and just do a separate problem here. Okay. So let's ask solve. When is, I don't know, x squared plus 3x minus 1 bigger than -x squared plus 10. Okay? When I make a problem up using kind of random numbers, you can generally assume it's not going to work out to be nice whole numbers like the book does, but that's fine. Okay? If a number is a whole number or a fraction or a radical, it makes the problem maybe a little more tedious, but it doesn't make it fundamentally more difficult. So I recommend make this something compared to 0. So I'm going to put everything over to the left side. I add x squared, so I get 2x squared. And I subtract 10, so I get -11. I want this to be bigger than 0. So this is a parabola that opens up. It is a concave up because A is 2, which is positive. Okay, so this is a concave up parabola. Where are its intercepts? Well, my x-intercepts are going to be solved by saying, where is this equal 0? So I want 2x squared plus 3x minus 11 to be positive. So, sorry, to be equal to 0. So I'd say, okay, let's apply the quadratic formula. I'm not even going to try to factor this. So x is -3 plus or minus the square root of 3 squared minus 4 times 2 times -11 all over 2 times 2, which is -3 plus or minus the square root of 4 times 2 times 11 is 88. It's positive because I had 2 negative signs there. And then I have a 9. And 9 plus 88 is 97. All over 4. Okay, now in another tab, I'm just going to estimate this. So -3 plus the square root of 97 all divided by 4 is about 1.71. Okay, so let's come back. So this is x is about 1.71. Approximately. And negative 3 minus root 97 over 4 is going to be negative 3.21, approximately. Or negative 3.2. So here are my intercepts, negative 3.21, comma 0, and about positive 1.71. We were a concave up parabola, which means the graph has to look something like this. We can find the vertex, but it's actually not so important. We just want to know, where is this positive? Well, it's positive to the left or the right of the respective intercepts. So left of intercepts will be x can be less than negative 3.21, or I could be right of all the intercepts. X could be bigger than 1.71. In interval notation, you would say this is everything up to but not including negative 3.21 union 1.71 off to infinity. Okay, and because the original inequality didn't include possible equality, I am not including these endpoints in the intervals. I would never include plus or minus infinity, but I'm also not including 3.21 or 1.71. Okay, so you can do inequalities that compare one quadratic to another. You could even do an inequality that compares a quadratic to a linear function. There was an example like that earlier in this section. It's fine. I would generally suggest always make it a quadratic compared to 0, find intercepts, and then depending on whether the quadratic is concave up or concave down, it's either positive between the intercepts or negative between the intercepts, and then the opposite outside them. So this was concave up, so it was negative in between and positive outside. If you had a quadratic that was concave down, it would be positive in between the intercepts and negative outside. And if a graph of a quadratic has no intercepts, it's either always positive or always negative. Okay, so that's the end of this section and this chapter. So we are finished chapter 5. So once you have worked through all of the homework and quizzes and all of that, come on back to chapter 4.